Okay, a few things for us to do here today. The first thing, you guys had an assignment due today. It was a worksheet, right? What I'd like you to do, make sure you have your name on that, and pass it to the kind of the middle of the aisles. Oren's going to come by and pick them all up. Now, the way I want this to go is, hopefully you did really well on this. We're going to take them, Oren and I are going to take them, we're going to punch in a grade based on the rubric that's in Blackboard. Okay, it's worth 18 points. If you get 18 out of 18, great. If you get something less than 18 out of 18, we'll give you a chance to go back and correct any mistakes that you made or something like that. So whenever you turn in an assignment of this nature, kind of like the one I'm going to give you in a minute, I don't want you to think, if it's like this project, like we're going to work on an Excel spreadsheet here today, I don't want you to think that as soon as I turn this in, oh man, I didn't know what I was doing, so I'm not going to turn it in, or I'm just going to turn it in and I'm going to get a bad grade. We'll take it, we'll look at it, we'll give you a grade in Blackboard, we'll give you a little feedback, give it back to you and say, see if you can fix this mistake, and this mistake, and then turn it again, and then you can get a higher grade. Okay, that's the way I want this to work. Unless you just nail it the first time and you get a terrific grade the first time, that's great. So, there's going to be two different things we're going to work on today. The first thing I want to work on is what I'd like you to do is just open up a blank Excel spreadsheet. Everybody has Excel on your computer. I'm just going to open up a blank one. We're going to do an assignment here based on quadratic equations, and I'm going to have it based on Excel. But what I want you to do is understand what cell references are and how we can use Excel as like a calculator and use the power of Excel. So let's do this. Everybody got their spreadsheet open? In cell A1, put the number 3. And in cell B1, put the number 7. And then go down to like cell C6, right there. Everybody there? Let's say for some reason in cell C6, I was interested in producing the sum of 3 and 7. Not necessarily just 3 and 7, but the sum of whatever is in cell A1 and the sum of whatever and B1. Okay? I want to add those two together. Anybody know how to do it? Go ahead, Katie.
Equals sum, parentheses, highlight A1, B1.
There you go. There's like 3 or 4 different ways to do this. We always start a formula with the equal sign. You guys taken CIS 170? Have you done some Excel stuff? Not yet? Anytime we want to put a formula in a cell, we always start with an equal sign. So go with the equal sign. And we could type the word sum, just like Katie said, and we could go sum, parentheses, the sum of what? Well, I could just click and click.
Well,
that didn't work. Drag. Yep, I'd have to drag like that. See how that one worked? I actually did 4. Let's just do those 2. And then I could hit enter, and notice how it spits out 10. See that? That actually is not the way I would have done it. I would have said equals A1 plus B1. Same exact thing. 2 different ways. There's actually lots of different ways to do this. I would just type it in. And I hit enter, and notice it produces 10. What I don't want to do is just type the number 10. Because later on, you might change this, let's say, to a 5. And if I change this number, I want this number to change with it. Does that make sense? So if I change this number to a 5 and hit enter, notice that my sum, it's not 10 anymore, it's 12. Do you see how by changing one, it changes the other? Because down here, I didn't type 3 plus 7. I typed A1 plus B1. Okay? And where I'm going with this assignment is mathematical standard number 2. Reason abstractly. I want you to reason abstractly. Instead of thinking of the number 3 and 7 or the number 5 and 7, I want you to think of these as variables or something that is residing in cell A1 or something that is residing in B1. It's kind of like a computer programming coding kind of exercise we're going to do here with Excel. So let's say I can, put whatever numbers I want in here, 6 and 9, now it's 15. let's say over here, I'm just going to pick a new cell, like let's say E2. Let's say over here I want them to be the product of the two, multiplication. So I'd go equals A1 times B1. Notice it spits out 54 because 6 times 9 is 54. I could do divided by, I could do the square root, I could do lots of different things. Let's talk square root for a second. I'm just going to pick another random cell. Let's say I want to take the square root of whatever is in B1. Equals, the shortcut for square root on Excel is SQRT. Equals SQRT, parentheses, B1. Close parentheses. So I'm going to take the square root of B1. Now when I hit enter, you should know that the number 3 is going to pop in there because 3 is the square root of 9. But if I change 9, say to 11, see how all of my cells just changed? Is this easy? Is this not too bad? Okay. So if we understand cell references, and you can practice a little bit more with this if you want. I'm going to close this spreadsheet now. If you got a little tripped up by that, I do have a little help video that you can watch again, or you could watch today's video, class video again, underneath Chapter 2. Underneath Course Docs and Links 2.5 Excel Spreadsheet Calculators. Build your own. Here's a short video tutorial. You can watch that if you want. But what I want you to do is open Quadratic Calculator Template. Excel XS. Right there. This is the spreadsheet that you are going to complete for your assignment. Okay? So, open this document. Notice it's just blank right now. There's no formulas in there. You will want to save a copy of this to your shared folder. Okay? So, first name dot last name dot quadratic solver. And then, obviously, you're not done with it yet. But eventually, when you're done with it, you're going to have it in your shared folder. And then Oren and I are going to go in and we're going to grade it. So what are we doing with this? Notice that there are 2 tabs. The first tab is quadratic formula. The second tab is complete the square. And I already went through the work of setting up the template for you. So the only thing you are coding, the only thing you're going to put formulas into are the blue boxes. The blue boxes. Okay? So let's look at the first tab, quadratic formula. Notice that I set it up so that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I ask you in row 11, calculate the discriminant and ignore the bonus for a second. And then I ask you at the end, tell me what the 2 answers are going to be. So what that means is when you have all the blue boxes coded, you should be able to go to your textbook or your homework or anything and enter any value of A, any value of B, and any value of C, and your spreadsheet's just going to spit out the answer for you without you ever picking up a pencil. Does that make sense? Everybody see what we're doing here? We're building our own calculator. Building our own calculator. Okay? So now I'm going to go to complete the square. Again, the yellow boxes are going to be your original equation. So if you have a homework problem that says 3x squared plus 13x minus 8, you'd go 3, 13, negative 8, and it would spit out the answer. All in one. If you have it coded correctly. Okay? And ignore the bonus for a second there. So I'm going to show you what a completed one looks like. Just so I can show you how this is going to work. I went through and actually coded them. But what I'm not going to show you is what formulas I put in the blue boxes. That's up for you guys to figure out. All right? So, here is a completed one. I just have a random example in here. I'm going to delete these. So, yellow is just my original equation. Notice everything else just has zeros and divided by zeros because I don't have anything in there yet. I got to enter numbers into the yellow boxes so that it'll spit it out. So I just grabbed one out of your textbook. So this is your textbook. This is number 264 from your 2.5 homework. Okay? We want to use 2, negative 3, and negative 1 as our A, B, and C values. If I were solving that equation right there, 2x squared minus 3x minus 1 equals 0. And then if I go to the solutions manual, there's my answer. So that's the answer that I'm going to get my spreadsheet to spit out, except my spreadsheet's going to spit out a decimal instead of a square root sign. Okay? So let's check it. So I'm going to go back to my spreadsheet. I'm on the quadratic formula tab. I'm going to go 2, negative 3, and negative 1. I'm going to punch it in. 2x squared minus 3, so I got to do minus 3 there, minus 1. And when I punch those in, notice that it fills it in. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. See how I just populated my my quadratic formula? So this is just for display. It says display it. This one is calculate the discriminant, just like what you just did in your Bellwork quiz. What's the discriminant? It's the part underneath the square root sign. How did I do it? I put a formula in there, right? And this one says display your solutions. And the solutions are 1.78 and negative 0.28. Now, if I go back to the homework solutions, if I were to punch this in my calculator and get a decimal of it, you would find out that it's the exact same decimal that my spreadsheet just did. Okay? Everybody with me? Okay. That's if I wanted to solve that by using the quadratic formula. Let's say I wanted to do the exact same equation, but I wanted it done by completing the square. Then I'm going to go to my other tab, which is complete the square, and I'm going to punch in 2, which I already have in there, negative 3, which I already have in there, and then let's change this one to a negative 1. Notice my answers are the same. Doesn't matter how I do this. I should get the same answers, right? But the learning activity here is for you to understand the structure, see the structure of completing the square. So I give you directions in column A. Make the coefficient equal to 1. How did I do that? Well, I put a formula in there, and a formula in there, and a formula in there. Move the constant and complete the square. How do you think I came up with that number for completing the square? We've done it a million times, right? You have to code it, factor it, apply the square root property, and spit out the final answers. Okay, now, I put up in the directions for both sheets, I said, note, if your solution gives you pound NUM exclamation point, that means somewhere you either divided by 0 or you took the square root of a negative number, which Excel, if it can do that, I don't know how to do it. Okay? So your assignment is to be able to handle any quadratic equation that has real solutions. Real. Okay? If it ends up having imaginary solutions with an I in it, don't worry about it unless you're interested in some bonus points. That's what the bonus part is all about. So notice here, this particular one I punched in, 2, negative 3, and negative 1, it had real solutions. And the bonus, it's irrelevant. You see how it gave me the pound NUM? It doesn't work. But what happens if I change this equation to one that is imaginary? So I change this to like, 8. Notice that if I were give you 2x squared minus 3x plus 8, that one doesn't have any real solutions. It only has imaginary solutions. So underneath my real solutions, there's nothing there. But my imaginary solution says it's 0.75 plus or minus 1.85405i. So that's for a bonus. So if you look at the rubric in Blackboard, you will see how we're going to score it. It's a 20-point assignment. And then if you can pull off the imaginary solutions, I can't remember how many bonus points I put in there, 5, if you can pull that off. Okay, I know I've been talking a lot. And some of you might be right with me. Some of you might be like, can you start over again? Okay. If you feel like this is daunting, just try to figure out 1 or 2 cells and see if you can get it. And trust me, once you get into the flow of this, it's actually quite easy. If you understand cell references and you understand the quadratic formula and completing the square. So I'm going to give you some time today to work on that. We're also going to work on a few other things from 2.6. So I want you to just kind of hang on to this thought for a second. Well, you'll have a little bit of time in class today to work on it, and pretty much on Monday, the whole day Monday, we're going to use kind of class work time. This is due on Wednesday. This is due on Wednesday before you come to class. So, again, I'm going to repeat myself. You can't show up on Wednesday and not have this in your shared folder and say, oh yeah, I didn't do that because I don't know how to do it. Terrible excuse. You've got to submit something, even if you only got 1 or 2 little parts correct, so that we can give you some feedback and help you work on it. Okay? Okay. I am going away from this unless anybody has any pressing question on the assignment. Okay. What we're going to do is we're kind of working on 2.5. That's the last assignment I'm going to give you in 2.5 is the Excel calculator. What we are going to work on is some other equations. And I'm just going to show you a little snapshot of the equations that you guys are going to practice. And I'm going to give you some tips and some ways of going about solving them so that we can get some practice. So these are the, there's actually 10 because there's a 5A and 5B. So these are the 10 problems, equations, that I'm going to have you practice over the next couple days solving. Remember chapter 2, I said a lot of what we're doing is we're just solving equations. That's it. Solve for x. Okay? So here's just kind of a bunch of random ones. Notice that some of these are different than what we've done thus far. Okay? So I'll come back to these in a second so you can practice them. But I'm going to give you just a little intro on what it is we're actually doing here. Let's see. Okay. So here's what we've done thus far in Chapter 2. We started out back in Section 2.1 with linear equations. Those were kind of the easy ones, mx plus b. Okay. Then we did the rational equations. Remember the ones where we had like x in the denominator? We had to get the greatest or the lowest common multiple. We had to get the common denominator. Those were a little more complicated. Then we spent a heck of a lot of time on quadratic equations. That's where x is squared, right? How did we solve them? We learned how to factor them. We learned how to use the square root property, take square root of both sides. We can complete the square. We can use the quadratic formula. We can graph it on our computer. There's lots and lots of ways we can come up with a solution. Okay, and now if you can do that Excel spreadsheet properly, you can just punch it in there and have that spit out the solution, right? So lots of different ways we've looked at that. So in section 2.6, they just give us a bunch of other kinds of equations that we haven't looked at yet. For example, what happens if we have an equation that is like x to the third power, or x to the fourth power, or x to the fifth, x to the sixth, something like that. What happens if we have a radical equation? That's one that has a square root sign in it. We're going to practice solving radical equations. What happens if we have an equation that has a fraction as an exponent? So not x squared or x cubed, but what happens if it's like x to the 2/3 power or x to the 3/5 power? Okay, we haven't encountered that yet, so we're going to practice some of those. What happens if we have an absolute value equation? The vertical bars, the absolute value of quantity, we're going to practice those. So here's some problem-solving strategies, and you don't have to scribble this down or whatever. You might be familiar with some of this, and this PowerPoint is on Blackboard. You can pull this up later. We've done x to the first and x to the second, but what happens if we had like an x to the third or an x to the fourth? One way of trying to tackle this is just trying to factor it. So let's say we had something x to the third plus something x squared plus something x plus something. Big, ugly equation. If it is factorable, we can factor it into a parentheses times a parentheses times a parentheses, set it equal to 0, and we can use our zero product principle. Just like we did with a quadratic, which has 2 parentheses. If it's x cubed, we'd have 3 parentheses. If it's x to the fourth, we'd have 4 parentheses, and so forth. Okay? So trying to factor it is one strategy. But we know that sometimes you try to factor a polynomial, and it just doesn't factor because it comes out to these ugly, awful decimals that you could never factor, right? So sometimes you just got to be clever in rearranging the furniture and trying to factor, and we'll get some practice at that. And the ones that we're going to give you in this section are going to be factorable equations. Okay. Radical equations, the ones with the square root sign in it. Okay, a little fill in the blank here. In section 2.5, when we were doing quadratic equations, if we had x squared and we wanted to get rid of the 2, how do you get rid of a square? So you square root it, right? You take the square root of both sides because a square root cancels a square. They undo each other, right? They're opposite operations of each other. So in section 2.6, we're not going to be solving x squared. We're going to be solving the ones that have the square root of x. How do you get rid of a square root sign? You square it. They're opposite, right? Because a square cancels a square root. So I'm gonna give you a little tutorial here. So there's something what we call an extraneous solution. An extraneous solution. Let me give you a quick example. And I'm going to do this. Hold on. This is what we call an extraneous solution. Some of you might know what I'm talking about here. Let's say I tell you that x equals 3. Fact. Everybody cool with that? X is equal to 3. And then somebody comes along and says, hey, you know what? I'm going to square both sides of that equation. And if I square both sides, I would have x squared equals 9. Was that algebraically legal, what I just did there? As long as I do it to the left side, I do it to the right side. Do you guys agree I'm okay there? So that was legal. I didn't do anything wrong, right? Somebody else says, you know what, I'm going to come by and I'm going to solve that equation for x. How would you do it? Yeah, square root both sides, right? So I would go square root, and I would say x equals what? 3? Or negative 3. How many answers do I have here? 2. X equals plus or minus 3. Hold on. How could x be both plus and negative 3 when 10 seconds ago I told you that x was only positive 3? I never told you it was negative 3. I just said it was positive 3, right? So I started out with x being only positive 3. I did a legal maneuver, and somehow I changed one answer into 2. Do you see how there's kind of a little hiccup in that process? That's what they call an extraneous solution. So if I go back to the PowerPoint here, extraneous means like above and beyond. It's extra. It popped in there and it wasn't supposed to be there. So sometimes when we solve a square root equation, a radical equation, we end up getting 2 answers, for example, and one of them might not even be a real answer. It might have just popped up through our solving process. So how do you check to make sure you're okay? You just got to plug your answer back into the original equation and see if it works, right? Okay. Solving equations with a rational exponent. We're trying to solve for x, but what happens if they give us x to some fraction, like m over n, some 2/3 or 3/4 or something like that? If I had a 2/3 or a 3/4 or a 5/6, how do you change a fraction into a 1? There's one specific way you can always change a fraction into a 1. Any fraction. Nobody? You guys are so bored with my lecture today. Times by the reciprocal, exactly. So if it's 2/3, if you take 2/3 times 3/2, you get 6 over 6, which is 1. If it's 4/7, you take it times 7/4. If it's 3/11, you take it times 11/3. Whatever, the reciprocal, right? So we take it times its reciprocal. Now we have x to the first power. So you're going to get a chance to practice those. Equations that are quadratic in form. We should know how to solve quadratic equations. Sometimes we have one that looks like a quadratic and we can kind of convert it. We got to be a little bit clever in order to pull that off. And then my last slide here is absolute value equations. You guys have seen the vertical bars, right? The absolute value of x. You need to know what the definition of absolute value is. I like to say that it's the distance away from 0 on a number line. So the absolute value of -7 is 7. Why? Because it's 7 units away from 0 on the number line. Okay? So we're going to practice some of those. So here's what I'd like you to do. I would like you to go to these examples. You could open this on Blackboard if you wanted to, or you could just look at the screen. I'd like you to practice these. Write them down on a piece of scratch paper. I know I flew through that. So I want to see what you can and cannot do. These are practice. These aren't for you to turn in. See if you can tackle some of these. At least get them all written down. You probably won't finish them all unless you're fast. You might be able to finish them before we're done with class today. Get them all written down. Give yourself plenty of room to work. And I want you to solve for X on each one. Now, if you're really wanting to start on that Excel spreadsheet assignment, you can work on that instead. So I don't care what you work on, whether it's this or the Excel spreadsheet. Oren and I are going to walk around for the next 14 minutes and answer questions for you, help you out, regardless of what you're working on. Feel free to talk to your neighbor.
Correct with some of these. If they didn't pick the quickest road, does it matter?
I don't know if there is a quickest. I'm more interested if
They got it right in there. Okay.
Yeah.
This one was factorable. So there's like 4 people that factored, but everyone else, it's fine? Okay.
Yeah. There's really no wrong answer.
And I'm assuming all of them are like 2. There's
All of them are what?
everything's
Oh, I got to show you the rubric. If you go into Blackboard. Was somebody raising their hand back here? I didn't. Yeah? No? Oh, you guys got on camera. This is basically what we're going to do on Monday as well. We're going to work on those Excel spreadsheet solvers, and we're going to work on this list of equations. Now, obviously, if you want to practice more than just what's on the screen, there's a whole host of these in your 2.6 homework in your textbook.
With that assignment that we just turned in,
Yeah.
Did you want us to do the bonus where we put the
If you wanted the bonus, yeah.
into
Yep.
shared folder?
Yes. Did you guys catch on the bonus for the one that you handed in earlier today? It said put a file in your shared folder. So if you did the bonus for today, you should have a GeoGebra file in your Math 103 shared folder for us to look at. Oren, go ahead and pull up your Blackboard. And go to the grade center. Yep. Go to 2.5 analysis worksheet.
This one?
Yeah, so just go like you were going to enter a grade for that student right there. So go to the drop-down menu. Go to the drop-down menu. Go to View Grade Details. And then go to View Rubric. So you would do that for every single student. Okay. And then you just got to click on the box.
Okay.
And if the whole thing, if you were going to do all that column or all that column, you can actually just click, go to the very top, and you can just click that word right there, and it'll fill the whole column if you want. But so some students will be like ding, 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 whatever, and then it spits out a...
So you said you could click this if they got 100% on it?
Yeah, so if you went like that, do you see how that...
Yep.
And then notice that it gives you an opportunity to type feedback.
Okay.
Like, let's say there was that.
Okay.
And you could say, double check your solution or something like that.
Okay.
Okay. And then the bonus, you might remember, was 3 bonus points for each part 1 and 2. So a total of 6 if they did it. So you could actually change it, type it in manually, but if you don't type it in manually, you just click save, and it'll give whatever you can ask me if you have questions. I'm going to exit out of that so you don't save it. So, did you get something to work?
I formula wrong. I had a star instead of the carrot.
Yep, but now you got it. Good. What do you got?
So I'm doing 2
Okay.
up there.
Yep.
And I took out like common multiples in both of them, so I got x squared, like 2x
Good.
plus 3, and I got 2x plus 3 over there.
Good.
So I just automatically go x squared plus 4.
Just make sure you don't you get it all on one side. That's really good what you've done. So what I would do now is I'd move this whole thing over to the other side, set it equal to 0. Yeah, exactly. So, because you'd have to subtract it, right?
Mm-hmm.
So it'd be x squared times 2x plus 3 minus 4 times 2x plus 3 equals 0. And now, right?
Yeah.
Now factor out a 2x plus 3 from each. No, you only have one side now.
Okay, yeah.
But from notice each of your guys has a 2x plus 3 in it. So if you pull out a 2x plus 3, your leftover would be x squared minus 4. And then you could factor that. And you'd have 3 parentheses. And you'd be good to go.
The first step in this one would be like taking out like a 4x squared both. Because they're both common.
You could. So then you'd have just 2x equals 12 left over. The only thing that is dangerous there is when you start with an x to the 4th, you know that in the end you are going to get 4 answers.
Yeah.
So instead of canceling out x's, I would try to move it all to one side of the equation. So like do 4x to the 4th minus 12x squared equals 0. And then instead of dividing and canceling, factor. What you should be able to do when you're all done, since that's x to the 4th, when you're all done, you should have 4 parentheses. 4 parentheses equals 0. Does that help? Yeah. See if you can factor it all out.
Where's this?
So looking at our notes, it says
Yep.
to square root both sides, get rid of the square.
Yeah. So let's see, where are you at right now? Which one are you?
The very first one.
Okay. So the only thing here is here's what's going to happen. You're better off if you were to square root both sides, you'd end up with x squared, but then you got the square root of 12, which is a pain in the butt, right? So instead of doing that, if you have an x to the 4th, blah, 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 you know you're going to have 4 answers, 4 solutions when you're all done, okay? If it's x to the 3rd, you're going to have 3. If it's x squared, you're going to have 2. If it's x to the 1st, you're going to have 1, and so forth. So what you should be able to do is take your x to the 4th, and I'm going to move the other one over, so minus 12x squared, set it equal to 0.
Okay.
And now I'm going to use my 0 product principle, okay? Meaning, if it was a quadratic, I would have 2 parentheses equals 0, right?
Okay.
But since it's a 4th degree, I'm going to end up with 4 parentheses equal to 0, and then I'm going to set each guy equal to 0. So can you change that into 4 parentheses, where it's something times something times something times something?
So 2 of them are not going to have an x. No, but
No.
2 of them would have to have an x. They would all have to have an x to get this.
Right. So there's lots of ways to do this. Maybe I say, what's common? This is x to the 4th, this is x squared. I pull out an x squared, right?
Okay.
What do I have left? X squared minus 12.
Okay.
Right? Well, this. Now I got 2 parentheses. Can I change that guy into 2?
X,
Yeah, there you go. Can I change this guy into 2?
x minus 12x.
Close.
X plus 12.
It's actually x minus the square root of 12 and x plus the square root of 12. Kind of unfoil it. Mm-hmm. You're on the right track, though. Yep. So just to give you a little idea here, for strategies, there's lots of different strategies for some of these. If I was doing this, let's see here. Whoops. Oh. Enable editing. Sorry. Okay. Finally. If I was doing this and I was looking at strategies, right away, this first guy, I'm thinking I'm going to try to factor him. I'm going to try to factor it, and I'm going to set all of those factors equal to 0. So you might have learned a long time ago, if you have some equation that's x to the first power, you will get one answer, right? If you have x squared, this is what we worked on in the last section, how many answers are you going to get? 2. What do you think you're going to get for answers if you have x cubed? 3. So what do you think we're going to get for answers for number 1? How many? 4. So if you're clever with your factoring, you should end up with a parentheses times a parentheses times a parentheses times a parentheses. Notice there's 4 of them, equal to 0. And if you can do that, then you can solve it just like you solved the quadratic by getting 2 parentheses, except you're going to have 4 parentheses. He said all 4 parentheses equal to 0. So that would be strategy, oh come on, for that first one. What would I do for number 2? I would try to factor that one as well. How many answers are you going to get for that one? 3. What am I going to do here for number 3? I'm probably going to get that radical all by himself, and then I'm going to square both sides because a square cancels a square root. Now, keep in mind that all of this takes a little bit of what we call procedural fluency. So, one thing I would not want to do is go like this and square both sides. Because imagine, take a look at what you're going to get on that left-hand side if you were to do that. You're going to have an awful, you'd have x plus 3 plus 6 root x plus 3 plus 9, and you just made it even worse than it was to begin with, right? So before I go and square both sides of that equation, what should I do? Get rid of the 3. If I want to isolate the radical, and then if I just square the square root of x plus 3, the square cancels the square root, and it's much, much cleaner. So again, just a little procedural step that's going to help you in that. And I don't expect you to master all of these right now, right? I expect you to try them out, try a few things, see if they work. Go to your section 2.6 in your textbook. You know, there's videos and there's examples at the end, and then try some of these and come back with these at least partially done on Monday. Maybe you get about half of them or a little over half of them, but you have a question on 3 or 4 of them, and then we'll use a lot, if not all of the time on Monday, so that you can ask questions and work on stuff from there. So same thing with your Excel spreadsheet. Work on that. You should at least have a start on it before you come back on Monday, and then we'll work on all of this on Monday. Okay, see you then.